So yeah, our goal for today's lesson is to find slopes of lines and rates of change. So we're going to take some time to do that. Review that skill today in class. Yeah, like I said, our quote for today is, nothing changes if nothing changes. Because ultimately what I need you to pull out of today's lesson is the idea that slope is a rate of change. And what you are actually doing in today's warm-up was taking a few minutes to just practice the computation behind our slope calculations. So did you see how you were doing a difference and then a difference and then dividing? That's commonly how we calculate our slope. Just a little tip. So number 1, the answer was -1. Number 2, your answer is 0. Number 3, that 0 with the slash through it, that's a symbol we use for something that's undefined. It's called the null set. Not that you need to know that, but I'm just giving you a little, what is that? 0 with the slash through it. That's what that's called. I just wanted to point your eyes at that because, I teach students in grades 9 through 12 all day. I have a nice mix, which adds a lot of variety to my day, and I really like that. Across the board, grades 9 through 12, I have students who have trouble remembering that 0 out of 2 is 0, but then -5 over 0 is actually undefined. So I just wanted to take a moment, if you fall into that category, to talk about when is your fraction equal to 0 and when is it undefined. So I'm going to first kind of go with maybe what you know. How do you know if, for instance, here in number 2 that you should have gotten an answer of 0, whereas in number 3 we got something that was undefined as an answer? How do you know that? Go ahead, Adam.
Because, I'm pretty sure the y's are on top, so for number 3, the x's are on the bottom and they end up with different y values.
Okay. I like that you're kind of drawing a comparison between the numbers on the page and maybe what they would represent on the coordinate plane. That's pretty cool. But we're going to divide lots of things in this class, not all of them making linear functions or having constant rates of change. So specifically, how do we know that this is a true statement and this is a true statement? That's what I'm getting at. How do I know? No takers on that one? You just do it because you do it? Okay. I like to talk about food. Like cake. So good. Let's talk about maybe something a little more concrete. Like if you had 0 out of 6 pieces of cake. If you had 0 out of 6 pieces of cake, because we're talking about parts to a whole whenever we talk about a fraction. If we have 0 out of 6 pieces of cake, you got no cake, and you are sad, because life without cake is sad. And then let's talk about this one. Let's do that upside down, maybe a little more concrete, not with negative numbers, but let's say you had 6 pieces, but there wasn't a cake to begin with. Having that cake the cake is not defined. There's no cake. It's not like there's nothing. You're grabbing 6 of, what are you grabbing 6 of? There's nothing to grab, right? So concrete-wise, that's why this guy here will always be undefined, and this guy here is always going to be 0. Because you can have no cake if there's 6 pieces of cake, but you can't grab 6 out of nothing. There's nothing to grab. The division is actually what we call undefined. You can't take something and divide it no ways. No division happened. So for that reason, we will always say a number over 0 is undefined. Now, sometimes my students have trouble remembering that, and they need yet another way of thinking about it. So here's the last way I encourage you to remember it. This comes to you courtesy of Pinterest. This is not something I came up with on my own. But what I saw another teacher do is they wrote it as 0 over a number, and 0 over a number spells the word on. It's like game on. You're going to get an answer. The answer is 0. Whereas if you have n, a number, over 0, a number over 0 spells no! So you're not going to have an answer. So that's undefined. So if you're looking at it, that spells no! So we got an undefined answer. So if you're confused, because it's a big part of today's lesson, hopefully that helps you out. Gotta love some Pinterest. Oh man, so great. All right, and then I just wanted to talk to you about the last couple things. So I'm glad we got that ironed out. Hopefully that helps you a little bit. Number 4, the reciprocal of 1/3 is 3. The opposite reciprocal, and this becomes more important. When we say opposite in math class, we're talking about plus or minus. When I say reciprocal, I'm talking about flipping stuff. We flip to get the recip. So if you have the opposite of 3/4, that's going to be negative. And then the reciprocal of it is 4/3. So put those two things together. The opposite reciprocal is negative 4/3. That'll be important because you know that we're going to talk about parallel and perpendicular lines. Okay, quick little review of slope. It comes at us in multiple ways. Well, because algebra does things multiple ways. We talked about all the different ways a function can be represented. You could have coordinates, you could have a t-chart, you could have a graph, you could have a mapping. Well, slope could come at us in words. Most commonly in words, it comes at us as a rate of change. What goes on the smartboard, friends, goes in your notes. When I say rate of change, you know, I might be talking about miles per hour. I might be talking about meters per second. That's usually meters per second. We're going to talk about broccoli consumption for humans in the United States over the course of a year. So we might say pounds per year is another one. These might be better served as commas now that I'm looking at this. It just looks like a bunch of fractions, and you're all terrified of those, so I'll switch those out. So miles per hour, meters per second, pounds per year. Those are all units that document rates of change. So you're talking about a slope. I think you're all very familiar with the formula, y2 minus y1 over x2 minus x1. But remember that this is just a calculation. We could do it on the graph by calculating our rise to our run. Rise is your vertical displacement. You like rise up in the morning, right? And then we run across the ground, so we run over. So that is our horizontal displacement right there. Okay, I want to see what you know real quick. Will you do me a favor, just give like, example 1 a whirl? Let's see if you can calculate slope real quick. Okay, final answer on that, I got 4/5. Does anybody need help with that? Okay, the trick, it's always in the fine print here. When calculating your slope, be sure to subtract the x coordinates and the y coordinates in the same and correct order. So you could do y1 minus y2 if you do x1 minus x2. More commonly, we do the y2 minus y1 over x2 minus x1. But as long as you're doing it in the same order, we would be fine. Everybody okay with that? I thought you'd be. I probably could have included that as a warm-up problem. Okay, it's also important to be able to look at a slope as a number and start to piece together what it's going to do on the graph. That is a big idea in this class. The goal for you, overarching throughout the course of the year, is to be able to just look at an equation and then your brain starts to automatically generate a picture of what that graph is going to look like. We actually are going to call them our famous dance moves in a little bit. We're actually going to get our first dance move next week. But what I wanted to talk to you about was how our brains can start to generate that graph for a linear equation. And that comes with classifying our slope. So the slope, just looking at that number m in our equation, the slope of a line indicates whether the line is going to rise from left to right, fall from left to right, is horizontal. Oh, that's messy, I'm sorry. Get bigger. Doesn't want to. Need more line there. Is horizontal or is vertical? Okay, so if you have a positive slope, your m is a positive number. Or we might say our slope is greater than 0, right? Because those are positive numbers. Yeah, let's do that. The big kids are going to write it as an inequality. Positive in math class means bigger than 0. If your slope is positive, your line rises or increases from left to right. If your slope is negative, so you have a negative slope or an m value that's less than 0, your line goes downward or decreases. So we could even say this is an increasing line if you'd like another word choice. Some of you love having word choices at your disposal. So this line increases. A negative slope is going to fall from left to right, so this is going to decrease. If our slope is actually equal to 0, we get a horizontal line. So the slope of that line right there is 0. This is what we call a constant graph. We talked about that when we talked about our worksheet that we went over yesterday. If you have the exact same y values all the time, you're going to get a constant graph. And then, if your slope is undefined, that null set there, you're going to get a vertical line. So this is where our slope is vertical. In other words, we don't have a function. It's failing the vertical line test. These are going to be functions of the form x equals a number. I don't know why I said functions. I should have said relations. These are going to be relations of the form x equals a number. We'll talk about that next week also. Everybody okay with that? All right, so now we get to classify our slopes. So in part A, it says, without graphing, tell whether the line through the given points rises, falls, is horizontal, or is vertical. So again, I'm going to go ahead and just take a second to calculate my slope. Because it says without graphing, right? So I need to be able to look at the number. So I'm going to do y2 minus y1 over x2 minus x1. So I get 5 over 7. 5 over 7 is a number that is greater than 0, which means our slope is positive. So using the chart we just filled in, when we have a positive slope, we have an increasing line, so this line will rise. How about you try B? So we did y2 minus y1 over, oh man, x2 minus x1. We have 3 over 0. That's a number over 0. That spells no! So it's undefined. What does that mean? Our line is vertical. Everybody good with that? Ah, you're persevering. Nice job. Okay, so word problem, word up. How can we apply this? And for this problem, I chose delicious fruit snacks. My kids eat them like by the case. I eat them too because they're delicious. All right, the chart below represents the number of small packs of fruit snacks. You know, if you imagine going to Giant Eagle, you know, or Aldi or wherever you shop, get those little gushers. Those are good. This is, you know, seems about right. You know, if I buy 3 boxes, I might get 24 packs. 5 boxes, I might get 40. 7 boxes, I might get 56 little packs of fruit snacks, you know, if I'm buying for the entire 2nd grade class at my kids' elementary school. We would find the slope of this line is the first thing we're asked to do. Then we're asked to, after we find the slope of that line, increase or determine if the line will increase or decrease. And then, oh man, your favorite word and mine, we got to talk about what that means, because this will be really important when we get to section 2.6. You have to interpret the number you find. So let's take a moment and find the slope. When we go to write equations of lines next week, and some of you said this yesterday in the lesson, how many points do you need to actually write an equation of a line? Ryan, do you know? 2. So I'm just going to grab 2 points here. Like 3, 24 is a point, and 5, 40 is a point. So I can actually write those as ordered pairs. I don't know if you heard me say it. I said 324 is a point, And 5 comma 40 is a point. And then I could just find the slope, right? So I could do y2 minus y1 over x2 minus x1. So we get 16 over 2, which is 8. Which is like 8 over 1, right? Well, if you think about plopping down what we actually did here, our y values represented our packs, right? And if we think about slope now, what's going on in the back of my head here? You're like, what is she thinking right now? I'm thinking about slope being that change in y over that change in x that we talked about. y2 minus y1 is our numerator. x2 minus x1 is our denominator. So if this right here is the change in our y values, and I notice that the units associated with our y values are packs, I know that that's talking about 8 packs. So if the numerator is talking about y, the denominator is talking about x. So what unit were we representing in our x values in our t-chart? Andrew? Yeah. So that's our explanation right there. It says, what does the slope represent? How would we say that in words? Anna? Perfect. So, like, literally, it's like a verbal model, right? We talked about that. It's kind of numbers, kind of words, put it together, gets you to an answer. So what we could say there's 8 packs per one box. Or, Hannah, you had a nice way of saying it too. There are 8 packs of fruit snacks. I really like that word per. I'm going to use it. There are 8 packs of fruit snacks per box. I like to go back through my question, make sure I did all the things it asked me to. So I found the slope of the line. That was this. Whoop. Will the line increase or decrease? Oh, forgot to do that. What do you guys think? It does, because it's a positive number. 8 is a number that's bigger than 0. So it increases. And we did explain what the slope represented. You ready to talk about parallel and perpendicular a little bit? See how it goes. So that's base calculation. This is a review from geometry. Parallel lines. Look at them. They're gorgeous. They exist like everywhere. But what I love about them is that, do you see I'm going to rise and run? And then I could do the same thing here, rise and run. And I've covered the exact same kind of space on my graph, which means the slope here tilts in exactly the same direction as the slope here. Parallel lines have to have the same rise to run throughout, or else they're not parallel anymore. So what does that mean with regard to our slope? The slopes of parallel lines are always equal. So the lines are parallel if and only if they have the same slopes. Perpendicular lines, however, oh my gosh. If I look at line 2 right now, so this is where my eyeballs are, that slope is increasing, right? It's going up, it's rising. So that slope definitely has to be positive. This other slope over here, line 1, it's decreasing. Oh, I swung and missed. Oh, so messy. Okay, so that slope there is definitely negative. So that's what gets them pointing in kind of the opposite directions. One has to be positive, one has to be negative. However, that's not the only criteria for being perpendicular, right? One positive, one negative line could just make an X. Or it could make like an X the other way. But we need these to be like a perfect T. That's where the idea comes in that we'll have one sort of steep line, and the slope in this picture isn't very great. We'll have one sort of steep line typically, and one sort of not so steep line. In other words, a very steep or big rate of change, and then a more gently sloping rate of change. And that is only produced from reciprocals. So slopes of perpendicular lines actually have to be opposite reciprocals of one another. I like to use my arms to explain this idea, which stinks because you can't see it on a video. But, so like let's say I had a slope of positive 2. So I go up 1 over, or up 2 over 1, up 2 over 1. It's a steep line, okay? If I did a slope of negative 2, I'm probably looking at that. That's not perpendicular. It has, you know, down 2 over 1, down 2 over 1, and up 2 over 1, up 2 over 1. But we don't get that nice perpendicularity that we need, right? So what I need is that negative slope to ease up a little bit. So to get that perfect 90 degrees, I'm not going down 2 over 1, down 2 over 1. I'm going to go up 1 over 2, up 1, or down 1 over 2, down 1 over 2, making it more gently sloping. So it's the idea that 2 and 1 over 2 are reciprocals of each other. So they need to be pointing in opposite directions, but one can't be as steep as the other. So that's how, I hope that visual helps a little bit. But if we just make one a little more gently sloping, then we get that nice 90-degree angle. So you need opposite reciprocals for perpendicular lines. So this is a little strange, but we could say that the slope of line 1 is just the opposite reciprocal of line 2. So you have a negative 1 on top of M2. That'll always produce an opposite reciprocal for you. Or if you multiply your slopes together, you get negative 1. So our last sort of example for today has us just deciding, are the lines parallel, perpendicular, or neither? So let's do the slope of line 1. We're going to do 5 minus negative 1 over 2 minus negative 3. So we're looking at 6 over 5. And then the slope of line 2, we're going to do 1 minus negative 4 over negative 3 minus 3. So we're at 5 over negative 6. Look at that. They're reciprocals, and one's positive and one's negative. So these two slopes here are what we call opposite reciprocals. You can abbreviate if you like. And that makes them perpendicular. Do you guys remember that symbol from geometry? Symbol for perpendicular lines? So like an upside down T. You don't have to write the word, you can just use your symbol. Do you guys remember the symbol for parallel lines? Yeah, just two up and down lines like that. So parallel lines we could write like this. Perpendicular, you can just go like that. It's legit math notation. Alrighty guys, there's your conclusion independent practice. See if you can give it a whirl there. That 2-1 practice worksheet I will get off of you on Monday. If not, it'll go on a notebook quiz. With picture day, I was just thinking about it. Attendance a little later on might be sparse, like in and out of my other classes. So it's probably just best if I get everybody all at once. The answers are up there, but number 2, part B, I didn't show all my cards. Just kind of gave you a partial answer there. You guys want to talk about it real quick? Why do I have to stay up later? Not getting them done by 11 o'clock. What do you think?
Because the rate you're going, it'll take 135 minutes to grade them all.
Yeah. I actually did it a different take. I actually calculated the new slope. So 90 quizzes, and I had 120 minutes to get it done. That rate is 0.75 quizzes per minute. But I'm not grading that fast. I'm only currently grading at 0.6 quizzes per minute. So I need to step up my game. So I did 90 over 120, got 0.75 quizzes per minute, which means no. I'm too slow. Okay, you do have some, a little bit of a worksheet. It should be super fast. You do not have the whole thing. please make sure you read your assignment sheet super carefully so you don't do them all, right? Please pay some special attention, give a little love to the word problems at the bottom. We'll probably talk about those when you get back on Monday. If you want to try the flip grid again over the weekend, that would be great. Also, the answer key again is on Google Classroom. So if you're really struggling and you don't know if you did them correctly, please do take a minute to look on Google Classroom for your answer key. It is more common that your answer keys are there rather than me handing out all that paper. So please make an effort. You all have iPads now. Please make sure you're checking. You can also, I did this last night too. I downloaded Google Classroom onto my phone just because I don't really carry my iPad everywhere, but sometimes I'm like, ooh, did I upload their answer key? Like last night I was laying in bed worried about your answer key. I was like, did I upload it? And then I like double checked. I was like, yes, I did. So I downloaded it on my phone and then I pulled it up. So it's helpful.